Unsere heutige Thema.
Hi everyone, today we are going to talk about market, low demand and
Sonunda Tekçesi, Sonunda Tekçesi.
Okay, hi everybody. I would like to have a lesson now, and this lesson will be in mathematics on the topic of fields of mathematics. And of course, I have this lesson to the students who study in the faculty of physics and mathematics, and their specialty is mathematics. And in this lesson, I will explain to you the fields of mathematics. So let's pay attention to fields of mathematics. Let's have a general overview over the fields of mathematics. In mathematics, of course, as you know, there are a number of types of numbers, and this is also called main number systems. And of course, as you see here, there is natural numbers, integers, rational numbers, real numbers, and complex numbers. As you see in natural numbers, there is not minus or plus. Just you can see only figures or just ordinary numbers like 0, 1, 2, 3, 4, 5, etc. And in natural numbers, there is no fraction. As you see, there is no numerator, denominator, and you can see only simple numbers here. Then we can come across integers. What is integer? Integers may be -5 or -4, -3, and so on. Then rational numbers. As you see, rational numbers is characterized with A and B, where A and B are integers, but B is not 0. Then this is rational numbers. Then we can come across to real numbers as well, and the limit of convergent sequence of rational numbers. It is also considered to be the limit of a convergent sequence of rational numbers. Then we can also see here the last one is complex numbers, and complex numbers are usually observed with root. And A plus bi, where A and B are real numbers and I is a formal square root of -1. And what does it mean? It means that this is somehow, some kind, this is the mixture of real numbers and real numbers and formal square, and this is altogether called complex numbers. I want to speak about 0, and 0 is often used in mathematics, while it is called nil in football, and it is called null in military, and it is called cipher in computer as a computer term, and it is also note. You can see note in mathematics as well, and O in telephone numbers. When we say telephone numbers, we do not say 0 or naught. We usually say O. For example, 2005655, and so on. Then natural numbers. As you see, natural numbers are like 1, 2. We begin from 1. And enumerate the numbers up to billions, millions, trillions, and so on. And when we go back to history of natural numbers, it dates back to even just before Christ. And the most familiar numbers are the natural numbers, and which is sometimes called whole numbers or counting numbers. 1, 2, as I said now, 1, 2, 3, and so on. And traditionally, the sequence of natural numbers started with 1. 0 was not even considered a number for the ancient Greeks. It means that ancient Greeks did not classify 0 as a number. However, in the 19th century, set theorists and other mathematicians started including 0, cardinality of the empty set. 0 elements where 0 is thus the smallest cardinal number in the set of natural numbers. Today, different mathematicians use the term to describe both sets, including 0 or not. The mathematical symbol for the set of the natural numbers is n, also written, and sometimes when it's necessary to indicate whether the set should start with 0 or 1 respectively. In the base 10 numeral system in almost universal use today for mathematical operations, the symbol for natural numbers are written using 10 digits from 0 up to 9. So what is mathematical operations? There are 4 elements of mathematics, and they are considered to be mathematical operations. And major mathematical operations are addition, subtraction, multiplication, and division. As you know, in addition, we add numbers, and that's why it is derived from the name of adding something, some numbers or figures. And then subtraction is derived from the verb subtract. Subtract, we can also say extract, but in mathematics it is usually known as subtract. And for example, in subtraction, in the operation of subtraction, there is minuend and subtrahend, and these are the elements of subtraction, of the operation of subtraction. Then, but in addition, however, we do not come across such a situation. Then, when we speak about division, we can say that in division there is divisor and dividend. And for example, 2 divided by 5 or 2 divided by 10 is or equals 5. We usually say dividend number first of all, then we say divisor. Then the last operation, mathematical operation, is multiplication. And in multiplication, we multiply the numbers, and for example, 2 multiplied 5 by 5 is 10 or equals 10. We can say both of them. And in mathematical operations, for example, we usually use in mathematical operations we usually use just numbers, as you know. And in multiplication also there are 2 sides, and one of these sides is multiplier and the other one is multiplicand. As I noted now, the history of natural number dates back to before Christ, and before Christ, the people, primitive people, the people belonging to primitive society used usually apples and different kinds of live objects, just objects, lifeless objects, and they counted this. Maybe the animals, they counted the animals like oxen or goats, and they were obliged to devise natural numbers, because they, when primitive society, the people living in primitive society kept animals as domestic animals, they were obliged to count them in order to know the number of their animals. For example, if one animal was eaten by a wolf or by any other wild animal, they knew that there was something lacking in the herd that they were keeping. And in this way, they began to they were obliged to use the numbers. For example, when they wanted to gather apples from the trees, they were obliged to count them in order to distribute the apples among the members of the family. For example, they were obliged to count. For example, there were 5 people in the family, and there should be 5 apples for each of them, and in this way they were obliged to count just lifeless things. And let's talk about integers. And integers are mainly negative integers and positive integers. There are two characteristics, two features of integers, and one of them is negative integers, and another one is positive integers. In negative integers, we see minus in front of the number figure. For example, -4, -3, and 0 is neither positive or negative, as you see, because there is no sign in front of 0 in this case. And positive integers, there is no sign as well in front of the positive integers. Integer. Another example for integer is examples of even numbers. As you know, there are two kinds of numbers. One of them is even numbers, and another one is odd numbers. Even numbers are 2-digit numbers, but however, odd numbers are only single, is composed of a single number. And as you see, we now took an example in previous slide. We took an example for negative integers and positive integers, and we see here that also between positive and negative integers, you can see 0, and it is neither positive or negative, as we noted now. And let's get a general information about integer. The negative of a positive integer is defined as a number that produces 0 when it is added to the corresponding positive integer. Negative integers are usually written with a negative sign, minus sign. As an example, the negative of 7 is written -7, and 7 plus with brackets -7 equals 0. When the set of the negative numbers is combined with the set of natural numbers including 0, the result is defined as a set of integers. Z is also written. Here the letter Z comes from German Zahl, meaning number, and the set of integers forms a rank with the operations addition and multiplication. The natural numbers form a subset of the integers, as there is no common standard for the inclusion or not of 0 in these natural numbers. The natural numbers without 0 are commonly referred to as positive integers, and the natural numbers with 0 are referred to as non-negative integers. And I'm sure that I could form a general information about integers in these lessons. Okay, now this is time for rational and irrational numbers. Rational numbers, what is a rational number? Let us describe it with a diagram. As you know, as you see, rational numbers is usually observed with numerator and denominator. What is numerator and what is denominator? Let us explain this. Numerator is the number which is below just a line, below the line, and this is numerator, but above the line we can see denominator, and integers. This is a rational number. This is also called rational numbers, and we see here integers inside the diagram. It looks like also a pie chart, as you see, and inside the diagram you can see integers with minus numbers. Then there is also one more pie chart like, as you say, pie chart like picture here, and in this pie chart the whole numbers are described here, and you can see 1 and under root 4, 3 and 0 as well here, and this is called whole numbers, but altogether they are called rational numbers. They are considered to be rational numbers. Then irrational numbers are observed with under root, for example, under root 17, under root 2. Even we can see minus, the sign of minus in front of under root, minus under root 11, and so on. Rational number. A rational number is a number that can be expressed as a fraction. What is fraction? As I said now, a rational number, another name of rational number is also fraction, and a fraction is usually observed with numerator and denominator, and with an integer in numerator and positive integer denominator. Negative denominators are allowed but are commonly avoided, as every rational number is equal to a fraction with positive denominator. Fractions are written as two integers, the numerator and the denominator, with a dividing bar between them. The fraction n represents n parts of the whole divided into n equal parts. Two different fractions may correspond to the same rational number. For example, 1 second or 2/4 are equal. As you see, in fractions, numerator is usually set with cardinal numbers, but the denominator is usually set with ordinal numbers, as you know. If the absolute value of m is greater than n, supposed to be positive, then the absolute value of the fraction is greater than 1, be positive next towards 0. The set of all rational numbers includes the integers, since every integer can be written as a fraction with denominator. For example, -7 can be written -7 1. The symbol 7 1, the symbol for the rational numbers is Q, and quotient also written, and Q is the abbreviated or contracted form of quotient. And now let's talk about the results of four main operations, four main elements of mathematical operations, and one of them is quotient. Quotient is the product of division, is the result of division. and product is the result of addition. Then no, excuse me, product is the result of multiplication. Sum is the result of addition, and difference is the result of division. And these are four results of four main mathematical operations. Then we see here a real number, and in real numbers also in general the numbers were described here in pie chart, and of course in sub pie charts inside one pie chart. And as you know, as you see, a real number is observed with the Greek alphabet P, E, and -2p, transcendental, and irrational. As you know, in irrational and transcendental, real algebraic and real numbers are crossed here, as you see, with one shaft. And rational numbers, as you see, in real algebraic numbers, we can see under root signs, and both under root and minus under root 3, and as well as like this one, and this is also this looks like fraction. Then rational number. What is rational number? Rational number, as you see here, it's also observed with denominator and numerator, and we can also see here the sign of minus, and as well as we can see here point, for example 2.25, and then whole numbers. Whole numbers are just colored with just violet or yellow color, and it is also observed with -1, -2, -3, and so on. Then let's pay attention to natural numbers. The most simple one among these numbers is natural number, because there's even a sign of minus in natural numbers. And natural number, the major sign of natural numbers is signed with n. The real number, the symbol for the real number is R, also written as, they include all the measuring numbers. Every real number corresponds to a point on the number line. The following paragraph will focus primarily on positive real numbers. The treatment of negative real numbers is according to the general rules of arithmetic, and their denotation is simply prefixing the corresponding positive numeral by minus sign. Minus 123.456. Most real numbers can only be approximated by decimal numerals, in which a decimal point is placed to the right of the digit with the place value 1. And what is decimal numbers? Decimal numbers are usually evaluated with 10, and each digit to the right of the decimal point has a place value of tens of the place value of the digit to its left. For example, 123.456 represents 1, 2, 3, 4, 5, 6, and 1000. Or in words, 100, 2 tens, 3 ones, 4 tens, 5 hundreds, and 6 thousands. A real number can be expressed by a finite number of decimal digits only if it's rational and its fractional part has a denominator whose prime factors are 2 or 5 or both. Because these are the prime factors of 10, the base of the decimal system. Thus, for example, 1/2 is 1.5, 1/5 is 1.2, 1/10 is 1.21, and 1/50 is 1.02. Now the last one is complex numbers, and in complex numbers, as I explained now, in complex numbers we can see the mixture of real numbers and pure imaginary numbers, and altogether they are called complex numbers. I want to complete our lesson with complex numbers, and that will be very good to share our lesson with you. And thank you very much for just watching this lesson, and so long.